Good afternoon, everyone. Is voice audible there? Okay, so here we can, excuse me. So here we can start our today's lab. Okay, first of all, I will discuss about the agenda, what we need to do. Okay, so first of all, I am going to explain the heading. What will be our heading from lab index? Second thing, I will explain theory behind your practical. Third thing, I will explain how you will prepare your lab manual for experiment 5. Okay, once everything will be explained from my side, then what you will do? You need to make a truth table, a logic circuit in your book. Once all things will be done in your book, then you will take the ICs, you will take the kit, digital kit, and you will perform today's practical. So in this way, this 2 hours will be spent. Is there any doubt? First of all, agenda of this 2 hours? Anyone? Okay. So here we can start with uh, lab index, right? So here in your lab index, we need to see today. Let me change the color. Construction of half adder and full adder, as well as construction of half subtractor and full subtractor using logic gate. And we need to verify this operation with our experiment. Please read the index carefully. Yes, you will be given to time to talk. You will be given some time to talk. Right now, just focus on the explanation. Okay, then sometimes in place of experiment 5, DF, students submit experiment 5 of DS. This kind of thing is happening. That's why clearly I explain all this thing. Okay? So this is your title of fifth experiment, right? Now we will start with theory behind it, and then we will talk about the lab manual, how you will prepare experiment 5. So first of all, let's start with design of half adder. Okay. So by means of the title, can anyone tell me which kind of circuit it can be? Is title readable there? Half adder, one title is given. So what may be this circuit? So adder means a circuit which can add something. That is called adder, right? Here half adder means a circuit which can add 2 bits. Okay, so input will be 2. Now can anyone tell me how many output can be there in this circuit? Think about it from here. If one circuit is there which is having 2 bit input, this circuit is adder, means it can add 2 bit. So how many output terminal can it have? 2 bit. Next. Think about it. Everyone will think about it. Yes, next. Sorry? 3 bit. કોઈ પણ બે માંથી 4 output. 4 output, girls. 4 output. See, we are not talking about encoder. Whenever you will learn encoder circuit, at that time output will be equal to 2 raised to 2, means 4. Have you calculated like this? 2 bit, so 2 raised to 2, so output is 4. Those who gave the answer 4 output, have you calculated in this manner? 2 input, 2 raised to 2. It is different circuit, that is called encoding. Right now our circuit is adder. He rightly said, very good. 2-bit outputs are there. How? Because whenever I am going to add a 2-bit, let's say 0, 0, please be attentive. 0, 0, output is 0. Carry will not be generated. Okay. Let's say I want to add 0, 1. Answer is 1. Carry will not be generated, so carry is 0. Let's say I want to add 1, 1. Answer is 0 and carry is 1. So any adder, output will be 2. 1 is sum, second bit is carry. Yes, the carry will be forwarded to next bit, but carry will be generated. Okay, so here, yes, very good for your answer. So here, first of all, definition. Okay, half adder is a circuit that will add 2 bits, means 1 bit, or I can say that 1 bit means 1A, let's say data A, 1 bit from there, and data B, 1 bit from there. So this bit will be added, this is called half adder. So 2 input and 2 output, 2 input, 2 output. Based on this, I can draw block diagram like this. 2 input, input name A and B, output name sum and carry. So now if 2 input, then I can make this kind of truth table. 2 input, so 0, 0, 0, 1, 1, 0, 1, 1. Is it so? Now see, I am explaining you half adder and full adder. Based on it, you will design half subtractor and full subtractor. I will help you, no doubt with this. But this thing will be prepared by you for half subtractor. Okay, so please be attentive. So 0, 0. Sum is 0. Carry 0. Next is 0, 1. Sum is 1. Carry is 0. 1, 0. Carry is, sorry, sum is 0. Carry, sum is 1. Carry is 0. 1, 1. Sum is 0. Carry is, so this is the truth table. How this truth table comes from? So first of all we define, means first of all we consider definition. Remember this thing. Every time you need to focus on definition. Based on the definition, you will decide number of input and output. After it, you will draw the block diagram. And based on block diagram as well as definition, you will prepare the truth table of any circuit. Okay. Now observe output column. How many output column are there? 2. Agree? So 2 function will be made. One is for sum. Second output function for carry out. Generally, we will draw the K-map to solve this function. Okay. Slowly and gradually you will have bit of truth table, long truth table. Right now, truth table is very much simple. So I don't need to use K-map. Directly, can anyone tell me what can be the equation of sum by looking at the sum column? So what is the conclusion of the sum column? If 2 input are same, output is 0. If 2 inputs are different, output is, which gate it represents? XOR gate. XOR gate, is there any doubt? Now look at carry out column. Which gate it represents? You must know truth table of every gate thoroughly. AND gate, is there any doubt? Right now, K-map is not required to solve this equation because it's very much simple at looking at it. So, by means of this observation, I can draw this circuit. My circuit in which 2 input names are A and B. A and B are given to XOR gate. Output of XOR gate is sum. Inputs, both the input A, B are given to AND gate. Output of AND gate will give me carry out. So this circuit is built inside this box. Okay, so this is block diagram where internal circuit is not shown. Once you will solve all these things, then at the end we will find its internal circuit. Okay. So once I will explain all this thing, what you will do, you will take your book, you will write half adder through table, then you will draw this circuit in your book. Fine? Then full adder. Now can anyone, okay, over here, one animation is given. So 0, 0 will be given to this gate. 0 will be generated as a sum. And output will be, carry output will be also 0. Okay, likewise, if I am going to give 0, 1, then it will be passed through XOR gate. Output will be 1, sum output, and carry output will be 0. In this way, I can get right summation at the output. So this is called half adder. Now, full adder. So can anyone tell me why half adder is already there? Why full adder is required? So let's say, please be attentive here. I am going to take this kind of example. Is it seen there? Is it seen there properly? I have written 1 0 1 1 0 1 1 1. Okay. So here, first of all, how many half adder will be required? Half adder will have only two terminals. One bit from one number, second bit from second number. So this is one half adder. Okay. 1 plus 1. This half adder will generate sum 0 and carry. It will be forwarded to next half adder. But now, will half adder be used here? Why? Half adder can only add 2 bits at a time. Now, how many bits should be added in this case? 3. 2 bits are actual from actual data, and 1 bit may be coming from previous summation case. Agree? 2 bits are compulsory. Okay. But 1 bit, carry bit, may be generated, may not be generated, depends on number. Here, carry is generated. But half adder doesn't have any extra terminal that can add this extra bit. It is having only two terminal, A and B. So this A, and only this 2 bit will be added. Half adder cannot add the carry which is generated from previous addition. So half adder will not be used in actual real-time practice as adder. So we can use full adder. Full adder can full adder can add 3 bits at a time. A, B, and C in. I hope you can understand now. A is actual number, B is actual number, and C in is what? A from previous summation. So from this, okay, so I can say 3 input and 2 output. Okay. So first of all, every time we will learn about definition. Based on definition, we will decide number of input and output. Based on it, we will draw the block diagram. What block diagram says? Circuit which is having 3 input, 2. You can give proper name. Based on it, we will make a truth table. So 3 input. So how many combination can be there? 8. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1. You will write it down by this fundamental. Then make sum column and carry column. So here sum column 0, 0, 0. Output is 0. C out is also 0. 0, 0, 1. Sum is 1. Carry will be 0. We have seen a simple addition in our first chapter, if you remember. So based on it, you will fill all this column. Now, look at sum column and look at theory column. You can make KML, 3-variable KML. Okay. Or else, if you don't want to make KML, better way is make KMF. Once this explanation will be over, everyone will make KMF for it. Okay. But right now, how this equation is considered, how it is written here. So from S column, wherever 1 is there, consider this 1. Okay. Then look at here, A bar, B bar, C. Have you found? A bar, B bar, C. So this equation is written A bar, B bar, C. Next one, A bar, B, C bar. So next equation, A bar, B, C bar. Likewise, 4, 1 are there in some column. So these 4 equations are written here. Whenever you will solve this equation, you will find final equation A, X or B, X or C in. A, X or B, X or C in. Likewise, you will make an equation from C column. Wherever 1 is there, you will put this equation. And whenever you will solve it, you will find A, B or A, X or B, C in. So you found 2 equations. One is for S, one is for C. From this equation, you will make a logic diagram. So what is first equation? A, X or B. So here 2 inputs are taken, A and B. They are X together. Output of it will be X or with C in. So final output A is equal to A, X or B, X or C. Then look at here, A into B. So here A and B are ended together. A and B. Output of this will be A and B. And here A, X or B will be ended with C in. Final, you will have this logic diagram. So if you will see this, it is actually 2 half adder and 1 OR gate. In your exam, in MCQ, this kind of question sometime asked. True or false? Full adder is a combination of 2 half adder and 1 AND gate. True or false? False, because it is combination of 2 half adder and 1 OR gate. Sometime you can be asked, full adder is a combination of 3 half adder. False, it is combination of 2 half adder and 1 OR gate. So this kind of MCQ concept can be asked. Now what is your role? What you need to do after this explanation? I would like to open your lab manual first of all. So here I have opened lab manual. Is it open there? In lab manual you will open whenever you will prepare. This is your experiment file. Okay. Now what you need to do in experiment 5, you will write the apparatus. This space is given. You need to write there something. Don't leave it blank. Then theory, you will write a brief theory of half adder, full adder, half subtractor, full subtractor. Then over here you are given the truth table and the circuit. Now what you will do? As I told you, you will make truth table and circuit in your book. In this lab only. So after this you will click the photo of your work done in your book. This photo should be pasted here. Half adder. And remove this truth table. You will paste your book work photo there. Fine. Then if you will go to half subtractor, don't worry about it. Once you will perform half adder, automatically you will perform half subtractor. Give some time to yourself. It will be automatically done. If it will not be done, I will explain. But half adder, bookwork photo, and truth table bookwork photo. Then same full header, you will draw full header in your book and put photo here. After all this thing, this is your book work. After all this thing, you will write procedure. After this, your simulation result means if you don't want to simulate it, you can take photo of your work, your kit, where LED is on off, and you can paste it here. Those who are present here, they can do things like this. Okay. Then conclusion and pre-lab and post-lab question will be taken from virtual lab. I already explained. This screenshot should be pasted here. Some MCQ are given in the lab, means only 10 MCQ are given. So in this way, you will complete your experiment 5. I have explained all these things up to your index title 2, your lab manual preparation. Now, is there any doubt? So now, can you do your own work now? You will prepare your first of all book. From this book, you will find IC now by your own self. Okay? Because students should do everything independently. I will help if you will not be able to find, don't worry. But first of all, try to find IC by your own self. You can take it from there, wire are there, divide your, we are having 4 kids. Okay, so in one group, 2 students will be there. Okay, so take this kit, take this ICs and implement yourself. This is now your work. Now, students are present here, they can leave the meet. First of all, your book work should be completed and then you can start your experiment. In book, you should write truth table, you should draw the circuit. Truth table there, you can use this truth table also. So you two are there. Kya wants to come in? Now, still 4 students are there. They need to divide into 2 groups. Okay, you can do your work. તમે લોકો girls અહીંયા kit લઈ લો. Kit already put in this cupboard from where you need to take out. Okay, student, those are online. Are you getting the point? Student, those are online. Are you getting the point? Is there any doubt? Everyone will make truth table and circuit in your book. In lab manual, Experiment fifth, you will paste photo of your book work. Right now, what you are doing, the work in your book. Same photo will be pasted in experiment 5. Okay. Once your book work will be completed, then you will open virtual. Please open virtual lab because in virtual kit, right now in virtual kit, X or IC is not available. So open virtual lab. In lab manual, experiment 5th, test. I put some instruction in the chat box. Online student, everyone will read it carefully. If any doubt, you can ask. So you can start your work, open virtual lab. For this experiment, you need to open virtual lab where you will find half header and full header. Open this experiment and explore it. After 5 or 10 minutes, you will be asked to share your screen. Everyone. Urvil, Vidhi, Shrey, Shubham, Vishnu, Shyam. Is there any doubt, anyone? Okay, so you will start your work in place of virtual kit. This practical can be done on virtual lab. Okay, so everyone will open virtual lab, make your connection, check the output, and verify your output with your truth table. After 10 minutes, you will be asked to share your screen.